In this problem, the probabilities of surgeries rated as very complex, complex, routine, simple or very simple are given here. We have to find the probabilities of these 4 combinations. Let us assume that E1 to be the event where the surgery is rated as very complex. Let E2 be the event where the surgery is rated as complex. Let E3 be the event where the surgery is rated as routine. E4 be the event where it is rated as simple, and let E5 be the event where it is rated as very simple. Therefore, from this we can say that P of E1, because it is given the probability of the surgery being rated as very complex is 0.1415. So, from this we can say that probability of E1 is 0.15. Then P of E2 is given to be 0.20, P of E3 is given to be 0.31, P of E4 is given to be 0.26 and P of E5 is given to be 0.08. Now, let us start with the first combination, that is complex or very complex. So, part A is complex is E2, very complex is E1. So, we want the probability complex or very complex. So, that means we want the probability E1 union E2. So, note that E1 and E2 are independent. Therefore, E1 intersection E2 is empty. So, that E1 probability of this is 0. So, now by addition theorem we have P of E1 union E2 is equal to P of E1 plus P of E2 and minus P E1 intersection E2. But as I told you, the intersection is empty, therefore, this is 0. So, this is equal to P of E1 is 0.15 plus P of E2 is 0.20 and this is of course 0. So, this gives us 0.35. So, this is the answer for the first part. Now, let us do part B, neither very complex nor very simple. So, this is probability of, now very complex is E1 and very simple is E5. So, something to do with E5, E1 and E5. Now, let us understand this. Neither it is. So, that means E1 bar and nor it is this, neither nor. So, there should be an intersection here. So, this is what we want, P of E1 bar intersection E5 bar. This is nothing but complement. You can write as well E1 complement or you can write E1 complement, or I am writing here bar. All the three are same, they mean the same. So, now what is this equal to? From this we can write P of, this is nothing but E1, we want to eliminate these bars or complements. So, this is nothing but P of E1 union E5 bar and still this is there. So, but this is equal to 1 minus P E1 union E5. So, that is what it is. Now, this is equal to 1 minus, what is P E1 union E5? It is P of E1 plus P of E5, then minus P E1 intersection E5. But again, E1 intersection E5 is also empty, therefore, the probability of this is equal to 0. So, we shall put the values. So, this is equal to 1 minus P of E1 is 0.15 plus P of E5 is 0.08 and this is of course 0. So, this is equal to 1 minus 0.15 plus 0.08 is 0.23. So, it is 0.23 and this on subtraction gives us 0.77. So, this is the probability of the second combination 0.77. So, we have done this. Now the next C part we have to do. So it says routine or complex. So probability of, now routine is the event E3, or means union, and complex is E2. Complex is E2. Be careful, it's complex and very complex. Both are there. We have simple, very simple. Both are there. So you have to be very careful here. So E3 union E2. So this is equal to P of E3 plus P of E2 minus again P E3 intersection E2. This is again empty. So this will be equal to 0. So P of E3 is 0.31. Then P of E2 is 0.20 and of course minus 0. This is equal to 0.51. So this is the other answer we have for part C. Then last one is routine or simple. So last bit is D. P, probability that routine or simple. Routine, where is routine is the event E3. So it is E3, or means so union, simple. It's not very simple, just simple. So simple is E4. This is equal to P of E3 plus P of E4 minus P E3 intersection E4. Again E3 and E4 are independent events, so this probability is 0. So this is equal to P of E3 0.31 plus P of E4 is 0.26 and a minus 0 for this quantity. So this is equal to 0.57 if you add. So this is the last answer, 0.57. So we have finished even the last bit. So therefore these are the answers 0.35, 0.77, 0.51 and 0.57. So that is the problem.